Hello everyone, Mike with Spray Jones, and we're going to get into a very important question, which is, does spray foam insulation need a vapor barrier? And it's the follow-up companion to is there waterproof spray foam that I had done previously. Before we get into answering this question, I just want to say thank you to everybody that has subscribed, checked out the videos in the past, given us a thumbs up. Appreciate having you here. Remember to check out the playlists and let you know that I am working on a lot of videos right now for bugs, electrical wiring, new ones on fire rating, off-gassing, and a whole section on doing this vaulted ceilings, cathedral ceilings, and shingle life, and vapor barriers, and ventilation. So stick around, it's going to be interesting. All right, on to our question. Does spray foam insulation need a vapor barrier? Well, we have to know what product we're talking about first, because it's not just a clear-cut answer. If we are using open cell foam, the answer is going to be yes. Now, here comes the explanations as to why. If we take a look at the technical data on an open cell foam, and I've got the technical data here, let's just scroll down to where we can see the physical properties. We will see that the water absorption rate is 74% by volume, but that's not really what we want to know. We want to see the water vapor permeance. So if we scroll here, we will see water vapor permeance is rated at 1,449 nanograms. Again, I've explained before that 60 nanograms is a vapor barrier, or 1 perm, and that this is 25 perms. So 25 times more permeable than what the vapor barrier is supposed to be, but quantified for a 2-inch or 50 millimeter thick piece of open cell foam, shaved, no top skin, no bottom skin. So open cellular format for all sides. Now, why does that matter? Because once you open up the cells, you're opening up the porosity of the foam insulation, and it's in its worst case scenario now for vapor diffusion. Now, I want to be clear. If you are in the United States, there are certain states that you do not require a vapor barrier, such as Texas. So if you're going to be in Texas or Nevada or what have you, you can go ahead and get open cell foam placed in your home, and all you're going to need to do is the air seal package. And we're going to get into why that is important next. But as far as vapor diffusion is concerned, you're not having to put 6 mil poly or a liquid vapor barrier on. So this only applies to the states or the countries that require a vapor barrier. I don't know what the requirements are in England or Australia or what have you, but in Canada, we very much need a vapor barrier due to our water flow and heat days. So if I was to select open cell foam in a 2x6 wall and I expect to shave that foam, I'm going to open up the cell structure and I am going to be required to place a vapor barrier in the assembly. 98% of the moisture that you have flowing through a wall is due to air leakage, not vapor diffusion. 2% is your vapor diffusion. So understand that controlling air leakage is the primary purpose of controlling water movement within a wall assembly. And this is for open cell, closed cell, bad insulation, you name it, any insulation type. Air leakage is your source of water. So the open cell foam applied into a 2x6 wall is going to control an immense amount of air leakage. It's not going to rate as an air barrier material because it can't meet the stats on its own. But you are not going to get an air draft from one side of 6 inches of open cell foam to the other. So right away you're controlling an enormous amount of air within the stud bay. The second thing that you want to do is every single seam that is in the stud wall is going to be caulked and stop the air from transmitting from inside to outside. That's infiltration or exfiltration of air. If you are going to control the air movement, then you've controlled 98% of the water. So in most situations, what they're going to want to see is 6 mil polyethylene or a liquid applied vapor barrier that meets the standards for the vapor diffusion that they're requiring. So you've got to get below this 60 nanograms or 1 perm with whatever product you're going to be installing. Now, I want to say something on the open cell foam. We have used open cell foam a lot where you cannot practically get in with closed cell foam, and it's going to be, you can't bat it. You can't close cell it because closed cell is just, you can't build it that thick, you can't build it that deep, you don't know where you're putting it, so there's only one choice. In a blind cavity, you're going to overfill the cavity with a product that is not going to burst into flames or thermally crack or cause damage due to high exothermic heat reaction on the chemical cure side, and damage like wiring or damage plastic piping or something like that, and that can happen if it's high enough and hot enough. So we'll use an open cell foam because we have no choice but to fill the cavity completely up. We will do that in successive layers, 1, 2, 3 layers. In each of those layers, there's skins. Now, a skin on the top of a foam is of a higher density than the rest of the cell structure. All right. If you were just to take the skin off and measure that density, it would be next to impossible to do it. But if you could, you would see that that density is miles ahead of what the actual cell structure is, because it's not cellular anymore. It's hard plastic. When you have multiple skins on open cell foam, I find that they do stop the water transmission, the diffusion. So going back to this sample, it's tested at open cell at 50 millimeters or 2 inches. So what happens if I spray 8 inches and there's 3 skins, top and bottom skins, within that assembly? What's the vapor diffusion going to be? Well, nobody can rightfully tell because there's no certified test to quantify that. I can't measure it. It's not just sticking a meter into it and taking a reading. This has to be done to a very specific ASTM test, E96. It's a desiccant dry cup test. I'm not going to bore you with the details. But what I am telling you, anecdotal from the field, is when we encounter residential, we did this on a commercial building, the corner was blind for a brand new bank that was being built. The architect had blocked it with I-beams and structural supports. There was absolutely no way of getting into that cavity. The cavity was at least a foot deep. They wanted closed cell foam at 3 inches thick for the whole entire building. We told them we can't get anything in there. It was closed up to the outside and scheduled to have masonry. So what do? The architect asked us, what do you do? Well, we used open cell foam, and what we had them do is we built it up through multiple lifts to build up the 12 inches. So there was at least 3 different passes in there, and then they put a piece of plastic on the inside as extra insurance just over that joint to help it. But as I had told them before, there's so many skins and so much thickness of foam that I believe that you have your 1 perm of permeability with the open cell foam. And that's something that if I ever had a desire to tweak, if I could answer some questions with suppliers, I would ask that they go back and test with multiple skins at multiple thicknesses with open cell foam to see what the vapor diffusion is going to be. So if you are a homeowner, building owner, developer, whatever, and you're looking to get somebody to put open cell foam in, and you're in the vapor barrier areas, you're going to need some sort of either liquid or sheet applied. Now, I find it's most common to shave the foam into the 2x6 wall and then just simply get the poly guys out and have them use the acoustical sealant into the joints, stop the air leakage, put up the 6 mil polyethylene so it certifies it as an air barrier material as well as a vapor diffuser, vapor barrier, and everybody's fine. They know that the poly is certified. It's exactly what the building code people are used to seeing, and there's no questions about it. And those are how we do our jobs. And then if we're into a situation where we need a liquid applied, well, then we have to get a product, a paint grade type product, a coating that would look and feel very similar to paint. I have one objection to using paint on cut open cell foam. If there is any delamination or if there's any movement within the building structure, the paint's not going to seal any of that up. At least with 6 mil, if the building twists, if a stud twists, if a seam opens up, you had it caulked, and then it opened up and twisted on you at a later date, at least you've got the 6,000th of an inch of plastic. between you and the drywall. So you've got added protection that is going to work towards providing that important air and vapor barrier to the inside. So I always stress that if we're going to be using a shaved open cell foam, that we at least use poly. Now, as you can well imagine, most people, you're starting to lose the advantages. If you have open cell foam and I still have to go poly, well then why don't I just bat it? And that's a great question, because most people want to get away from the poly, away from the acoustical sealant, and they want to get to a simple one-step system. And that's why most people go closed cell, and that's why we're going to take a look at next is the closed cell foam and what to do with that. Now, I didn't think it was going to take that long to get through the first section, but there it is. I know I don't like to be long-winded if I can help it, but this is a very complex and deep subject. So now we get into the closed cell foam and the vapor barrier properties. And the answer is yes, closed cell foam is a vapor barrier. But now let's get into how do we go about proving it and why, and what do we have to do. You need to understand that most of your codes, whether you're in the US or in Canada, make allowances that cellular, fibrous and cellular products are two different things. So a closed cell foam, such as extruded polystyrene or EPS, expanded polystyrene, they do not treat polystyrenes and plastics the same way as they do fibrous, whether it's mineral fiber, blow-in, or what have you. So fibrous is requiring a vapor barrier, and if you're using a sheet product, rigid insulation, cellular plastic of a closed cell nature, you're not required to put an additional vapor barrier. It is the vapor barrier, and most of the codes are written that way until we get to spray foam insulation, because all of a sudden spray foam insulation is manufactured on site by the installer. It's coming in two components and it's being manufactured right at site. So they don't have a line in their code to allow for regulations on spray foam. So we encountered this in 2008. We actually had some other spray foam companies that had gotten into business, and as it happens when you have a lot of other installers, some people's work isn't up to snuff, and water starts coming in, frost starts coming in, there's water damage in a structure, and all of a sudden the building inspector says, whoa, wait a second, stop, we're not entirely sure that this spray foam is a vapor barrier or should even be treated as such. So this opened up a can of worms where we had a professional review done where our actual city requested that the entire province, so it would be the equivalent of your state, review whether or not the spray foam was a vapor barrier, and they needed to have professional building science, professional engineers weigh in on the situation because they were in a quandary. The technology had advanced to the point where the code had not kept up. Now, I apologize that I'm going into such detail here. This is not going to be for everybody, but you need to understand that if you're going to be claiming that closed cell foam is a vapor barrier in your state, your county, your province, you need to know what the technical specs are and how we got to this. So we had Morrison Hershfield. Morrison Hershfield was asked by Spray Jones, Saskatchewan Inc., to provide generic details and specifications for application of BASF wall-type medium-density spray-applied polyurethane foam insulation to all exterior walls, underside of roof sheathing, to conform to a building standards opinion regarding the use of spray-applied polyurethane foam insulation for the province of Saskatchewan dated May 2008. By the way of qualification and bias, I note that I am a professional engineer, I am a building scientist specialist, I have professional history of building products, research products with BASF. So if we scroll down, and it's really interesting that they answered this for unvented roofs. I'll be doing a video on that. But if we get to the functionality of the vapor barrier, here we go. They're saying that wall-tight has a low permeability of about 125 nanograms for 25 millimeter that's not tested on the substrate. That's the actual product itself with no top and bottom skins, so that the thickness of a greater than 50 millimeter can provide its own vapor diffusion control to meet this intent of sections 5.5 of the National Building Code. So what they're stating is that we are going to be below the 60 nanograms when we're 2 inches of core density. But as I've said before, here's the chart that you have to look at for water vapor permeance. You have to check your OSB, your plywood, your Dens glass. They also have concrete, and they're going to give you the water vapor permeance of the substrate, and then the substrate with a 1 inch or a 2 inch application of the said amount of spray foam. So here we see it 2 inches thick. It's nanograms of 53. Again, 60 is required to pass, so it's below the 1 perm or the 60 nanograms. And on 1 inch, they're achieving it on OSB board at 14 nanograms. So we were able to prove that the core density, along with the set amount of spray foam, 1 inch, 2 inch, 3 inch, whatever, on the substrate, was below the water vapor permeance rating for the building code for a vapor barrier. So it didn't act like a vapor barrier. It wasn't a vapor barrier retarder. It was a vapor barrier on the substrate. And no, there's not an issue of, am I going to have frost and ice in the middle of my spray foam? See, in order for you to have water damage inside your insulation, you first need to have a condensing point, and you need to have an area where the air loses the water in suspension. In closed cell foam, all you have is the medium material of the polyurethane plastic, 1.5 million cells per cubic inch, charged with this freon gas. There's no condensing point within the assembly where the water can come out of air. The air is not it's not transmitting through. The air does not go through the closed cell foam where it can get to something cold enough where it will lose the water out of suspension in the air and form ice and form damage, you understand? So it isn't that we have an issue 2 inches in or 1 inch in and that we're going to have frost and ice at the roof deck. Back to this discussion about 98% of your water in a wall is from air leakage. When you install closed cell polyurethane foam in a stud above grade, you have got to caulk the seams. You have got to stop the airflow when you have wood-to-wood joints. Wherever you have 2 pieces of wood meeting, you have got to have caulking in there, because we are not going to go and put a vapor barrier up. Think about this. You do not need to worry about the studs themselves, because the stud, the wood, actually has enough water vapor permeance in the wood assembly to be a vapor barrier on its own. And you'll get that out of a chart. Most manufacturers of lumber will have a chart on the water vapor permeance of fir or spruce or whatever lumber that you're using. So you will find at a very thin thickness of wood, whether it's solid or whether it's plywood or what have you, that you already have the water vapor diffusion. So we don't need to go and put a strip of polyethylene on the stud face. We don't need to put a little bit of asphalt or a coating on the stud face. We don't need to worry about the studs. So we have water vapor permeance and insulation between the studs. We have the actual stud providing enough thermal insulation and enough water diffusion that it can stand up on its own, and it's not going to rot out. It's not going to be destroyed. So all that's left now is the wood-to-wood seams, bottom plate, double tops. Here's a wall. Here's Morrison Hershfield's drawing. Here's the spray foam. They're calling for 3 inches closed cell. And then what are they calling for? At every seam, they're calling for every seam to apply sealant at all joints in wood or perimeter of column to gypsum wallboard, right? Bottom plate has been caulked, right? And then the verticals are caulked, right? They're even going as far as showing that some sort of a seal is done for the 2x6s out where the edge is, and that's probably right. And nobody's going to do it with foam. Again, seal. This is a top view. 3 inches of foam sealing into the corner, right? This doesn't show it on the seams. It shows it sort of as airtight drywall. That's sort of wrong in my opinion. But I've encountered a lot of guys that don't do the caulking. They don't even know what you're talking about, and it's become a major part because this is airtight, this is airtight, this is watertight, this is watertight. So where's the air and water going to go through? Right through the seams. Now, if this is caulked with something that's going to last, and it better last it better be a high-grade silicone, not some cheap product that is going to peel and crack and split in 5 years' time or 2 years' time. You've got to be using a high-grade building envelope sealant. Acoustical sealant is by far the cheapest, easy, most readily available product to go and get, and that's why so many people put the tar inside. But we use something better than that, which is sprayed into the joints, troweled out, and I'll be doing a specific video on that. But this is what is going to finish your vapor barrier assembly. So the spray foam does achieve the vapor barrier ratings, closed cell. In most cases, it's not 2 inches. The reason that people say 2 inches is because that's what the core density is checked at. No top and bottom skins. So I've talked way too long on this, I think, but no condensing point is within the assembly. You don't use plastic with plastic. Get the right closed cell foam, and it is a vapor barrier. Install it to the correct thickness, and do your air seal package to work as an assembly for air barrier and vapor barrier, and it will work just fine. If you have non-break or continuous spray foam insulation, you don't need additional caulking, such as in a basement. And if you're using open cell foam, make sure that if you're shaving the foam and opening those cell structures up and you can't build multiple skins up, that you make sure that you're getting a high quality 6mm polyethylene and caulking, and everything will work out fine. If you do this, if you control 98% of the air leakage from inside to out and vice versa, you will control 98% of the water in the wall. Now, talking about rain and flashing on the outside is a totally different conversation. We're talking about building envelope and air leakage water here. So, I hope this has been of value. I hope you've been able to stay this long and understand what this little tutorial has been about. Click on the like and subscribe, and leave your comments here. I'd really like to know what you guys have to think if you've stayed this long. Thank you so much, and we'll catch you on the next one.